So we're going to start by playing a bit of buzzword bingo, because I'm very lucky in my role. I get to go to a few conferences throughout the year, so I've been harvesting some of the buzzwords. We heard some of them this morning, and we're going to see how you guys go. So the question for you, I'm going to put some buzzwords up, and you probably heard them all, but the question is, imagine you're at a dinner party and it comes up, would you put it down and explain it to your friends, or would you just pass, okay? So get your phones out. Whoops, yep, hang on. And go to either the QR code, if you can point your phone at it, or slido.com with 3456 as the code. All good? And once you're there, answer that question. Here we go, starting to come in. Okay, AI is looking pretty good.
Should have said, could you explain this in 25 words or
Yeah. Well, that's a tough call. Cool, interesting. That's good, okay. So everyone's got a pretty good idea, and that's good. This is good, okay. Two main ones we're going to be talking about today is AI and IoT, so it's good to know that there's a good understanding in the room, because we can build on that. Interesting to see the one down the bottom here, which Industrial Revolution 4.0, not getting a lot of hits. So I'm going to talk a little bit about that in a sec. Actually right now. So I was at a conference about 6 weeks ago called the Future of Work Summit, and had lots of presenters there, Salesforce, consultancies and whatnot. And what was interesting is that obviously no one had talked or briefed each other beforehand, so everyone pretty much got up and gave exactly the same presentation. But that was some interesting mining of trends. Everybody was talking about Industrial Revolution 4.0. I did a brown bag at DS a couple of weeks ago and asked for a show of hands. There was probably 30 or 40 people who had heard of this, and like 2 people. In this room, who's heard of Industry 4.0, Industrial Revolution 4.0? Few people, but it's just really interesting to me that in a bit more of a businessy kind of hand-wavy audience, everyone's talking about it. In terms of people like us who are going to be putting this into practice, not much awareness. So as you can see here from this diagram, what it's referring to, it's saying we've all heard of the Industrial Revolution, the first one that happened around steam power and whatnot, and this idea that we had mass production and we're basically coming out of the digital era. But Industry 4.0 is all about the bringing together of digital and the physical. So it uses transformative technologies to connect the physical world with the digital world. So automation and robotics, machine-to-machine or human-to-machine communication, AI and MEL, and the sensor technology and data analytics. So it's really the bringing together of these things that's going to transform the way that things are made and the way that we work. So that's one of the buzzwords that's floating around, but it's gaining a lot of traction, and it's certainly part of what we're seeing in the industry, and there'll be a case study a bit later about that. I'm always kind of partially nervous and disheartened, partially relieved when something I'm planning to talk about comes up a lot in the opening keynotes at LAST. So twice today from Nick, and I missed the name of the lady from the Singularity University, Christina. Okay, so big themes around this idea of exponential change. This was the 2 things at the Future of Work conference everyone was talking about, Industry 4.0 and exponential change. So I think we got some good overviews of what that means from the speakers this morning. But just that idea that, where was Facebook 15 years ago, and obviously now so dominant, smartphones, the rest of it. For sure, there's big changes, bigger changes, introduction of electricity and whatnot over the decades and centuries. But what we're seeing is the cycles are getting much, much shorter. Things that come up within 5-10 years are suddenly really dominant. I'm living this out at the moment. I'm doing a consulting gig in a small telecommunications company, and it's basically assumed that within 5 years things are going to be so different that that's the timeline that we're even thinking within. You're not even building a business case to think 10, 15 years out for what we're working on right now. We know that things are going to change that fast. So it puts a lot of pressure on being able to deliver really quickly and get your learnings happening really fast. And the third one here is this idea of post-digital. I think it's fair to say that having a web and mobile presence is just table stakes now. It's not negotiable for businesses to not do this stuff. So that's good for us right now, I think. I think a lot of us are really busy and in really high demand, satisfying these types of applications, the web, mobile type things. But that's becoming really, really common, almost commodity-like in the way it's built and delivered. But the question is around what's next. So I'm just going to talk a little bit about this Future of Jobs report from the World Economic Forum. This one was out last year. And just skipping to the bit about Australia, got this cool chart. And just to focus on the top right up here around technology adoption and the types of tech that we're anticipating seeing coming out in the next 5 years or so. So you can see from there some of the buzzwords we were talking about just before: AI, MEL, cloud computing, augmented reality and virtual reality. Not so much, we've got the app and web-enabled markets, but you can see a lot of what's dominating that list is emerging technologies and things that involve some wearable electronics, the Internet of Things. There's physical component to it. Skipping ahead to and you can see here the types of emerging job roles, quite technical looking. Developers and analysts. Be nice to be a CEO. They're going to be in demand, but I'm not sure that's something we should all be aspiring to. Data analysts. Quick show of hands, how many people here would consider themselves like, developers, hands-on coding tools? A few. Versus people like me, hand-wavy, Wrangler, Agile people. Yep, a few more. Cool, okay. So I look at that and I go, oh, okay, should I be feeling nervous or not? Because it seems like the emerging stuff is around these sort of harder science type roles. However, going to the next page, we get a little bit more comfort, hopefully, because the emerging skills is all the stuff that we're used to talking about and know and love around. Again, that came up in this morning around the creativity, analytical thinking, those problem solving, those kinds of things. But really all of this is going to need to come together. And this is the point of this Future of Jobs report, is to say there's not only the emerging tech, the AI, ML, all that kind of thing, but then there's also these types of skill sets that need to come together. So the question that we're exploring today is, what does this mean for us? And with this sort of professional development lens, I'm getting this general sense as part of the Agile community and the conversation that we're all part of every week is, Agile is, it's almost ubiquitous now. It's almost starting to eat itself in a way. You look at what's going on in some of the big organisations and whatnot. I'm starting to get this feeling of what's next. How do we differentiate the way we all think and the way we want to move business and society forward? And use these skills and start keeping ourselves sharp, because I think the Agile thing, at least I think it's fair to say for the LAST community, is something that we know and we want to spread it, but we've also got to think about what's next. So I'm going to dip into some case studies now and talk a little bit about AI to start with. So it was good from our list before, see if anything's changed, but no, it was still 84% of you could confidently describe it at a dinner party, which is awesome. You can tell me if you disagree with any of my quick summary here. You might have seen this picture before, which shows artificial intelligence is quite an umbrella term. Machine learning as a subset of that, which whereas AI started around in the 50s, machine learning more like in the 80s, and then deep learning is a much more recent type concept, and it's basically It's much deeper layers of neural networks. So taking machine learning, but amping it up. One thing I love about doing these types of conference talks is that I've got an excuse to talk to interesting people and ask them questions. And as part of my research, and as part of doing that, I hadn't heard of this model a couple of weeks ago, but I found it really interesting to come across. It's called CRISP-DM, the Cross Industry Standard Process for Data Mining. But I think it's a really useful diagram to help understand what the process is like for actually trying to engage around an AI type project. So this, where you start with the business understanding, data understanding, data preparation, the modeling, evaluation, and then into deployment. And you can see there's a bit of an iterative, there's a loop there for sure going on. And from speaking to our experts in-house at DS and some other people that are working in this field, these are some of the really key challenges that come up. And this one up the top around the data readiness is the really big one that keeps coming up, is that we get a lot of people coming to us, writing the buzzword wave, saying we need an AI project. But then once we get in there, what state is their data in? Because some things about AI MEL, you need a lot of it usually to be able to do the training, and it needs to be in a state that you can start training models on. So that is one of the really big key dependencies and a major pain point that we're seeing a lot of organisations need to tackle as they want to start this journey. It's also really interesting to understand that I think, unlike when we roll in to do a web or mobile type project, I think we just take so much experience and well-established patterns for granted. We've got a fairly good idea of what's going to be involved. Obviously, we want to use some more modern languages or approaches, and it allows us to focus heavily on the business problem. But what's interesting with this field is that it starts, this is this point down here on the right, around the literature review. Things are moving so quickly that the first part of an AI MEL project at the moment starts with hitting the books. So it's really interesting that a lot of the practitioners come from an academic background, and they've got that strong competency of we start with a literature review, we understand what techniques have been applied to this problem space before, what are the emerging ones, and then crafting an approach from it. I don't know about you guys, but when we start a web or mobile project, we don't start with a literature review. Maybe some research around some what framework or what not to use, but certainly not starting with that sort of academic frame. And then this third point down here around as you get into the evaluation, assessing the score, because an ML and machine learning type project, you're basically coming up with a confidence rating around the question that you're asking it, or the insight that you're trying to get through that training. And it's a bit different to building an app and trying to see if you've got product market fit by will people start to use it. It can be complex and risky to know, are we asking the right question, and is this answer that we're getting from the algorithm something that we can depend on? Is it something that people can make business decisions on the back of? Quite harder edged and a bit of a different shape to when we're navigating our usual web and mobile type projects. So when we think about applying Agile to this area of data science and what works well and what the challenges are, some of the things that we're accustomed to doing, like doing the periodic planning and prioritization, working in time boxes is quite well suited to that style of working where you're gathering data and training models. And of course, doing demos and retrospectives and reflecting, they all apply quite well to working with data science. Where there's big challenges is around, there's a lot of difficulty in estimation. And I know there's some people that don't like using the estimation word, but still it's important, right? If you're going to sit down and give someone a sense of what it's going to cost to tackle this problem, how long it might take. Again, our experts in-house at DS tell us it's going to be really hard to know. Sometimes things can fall together quite quickly, in a matter of weeks. Sometimes it's a matter of months, and it's very hard to say up front how long it's going to take. This actually can be a bit disconcerting when you feel like the score is coming together too quickly. When it's, could this be a false positive? You know, there's this kind of feeling as you're broaching the data science that it's hard to estimate. The rapidly changing scope and requirements can be difficult to navigate in the data science space. And the expectations for engineering-like deliverables after each sprint. I think we've got really accustomed to being able to show working software every 2 weeks and keep our stakeholders engaged and expectations managed. It's quite a different process on an artificial intelligence or machine learning type project. So, one of the key sort of takeaways from this, and to put it in the LAST context, so some ideas around being hypothesis driven and minimising waste are the key insights that I took from the conversations I had with data science practitioners around how to apply Lean and Agile, and they fit quite neatly under the L of LAST, the Lean banner. So to whiz through some a quick example of something we're working on at DS is a machine learning backed product called DataRock, and we're doing it in collaboration with a mathematical geology company called SolveGeo. And the way that's shaping up is, I'm not sure if you've seen these things before, they're called core samples. So basically when they're assessing a mine, they'll do these, they drill these core samples and they end up in boxes like that, going down, sometimes tens of meters. And historically, they've just been used for record-keeping purposes or for just a geologist would look at it or maybe do some chemical analysis. But what SolveGeo are doing is applying machine learning to do things like to be able to detect veins under the earth or to see how the rock fragments. And that's really valuable information for people looking at extracting value from that mine, basically. So we've been working with them on that, but in terms of building a product from it, we started by, just as a consulting model, they'd bring us hundreds of images, we'd train models around it, and through that we came to understand the data and the customer needs, but then we found that there's an opportunity to build a product and a platform around that, to put some workflow into it, so it's no longer just data scientists building a machine learning model, but it's now a much more holistic effort to build a web application where people can upload images, put it through a model and get insights out of it. So that's been our experience of creating a product that uses an element of AI, but then also brings together everything that we know from doing, customer-facing web type development and bringing those together. To move on to the next case study is around the Internet of Things. I'll just check our, that was our next highest, only closely behind. How did I do on AI, by the way? Did that match, just thumbs up, thumbs down? Did it match people's sort of, yeah? Okay, cool. So Internet of Things, billions of physical devices around the world that are now connected to the internet, collecting and sharing data. So as we know, smartphones maybe fit into that, but certainly things like watches, Fitbits, fridges that connect to the internet, all those kinds of things. Which is that one? Do you have another example? Vacuum cleaner. As the list goes on, it's getting endless. And obviously it involves hardware, and it's a bit of a cheesy thing to say, but hardware, it is freaking hard to work with and to develop products around. That's certainly been our experience. So at DS, we're working on this device called a power sensor, which we kind of say is like, a Fitbit for your home. So you can attach this device to a cable and it tells you how much power is going through it. But where it's unique is that it's pretty much this point up here that you can, a consumer can install it themselves, because the other products in the market require an electrician, and that immediately costs a few $100 to get behind your switchboard, and that increases the cost greatly. Whereas, for a fraction of the cost, this device can be posted out, people can put it on themselves and start to monitor their energy in real time. So we've been on this journey of creating this, and this is a bit of a visual of how it started, and I love the story. If anyone's been to the DS office, you'd know, down the back now, we've got a few embedded engineers who are the kinds of guys that arrive really late in the day and work late into the night, kind of the mad scientist type. And the story, which I believe, is they were late one night mucking around at the bench, I think with a joystick, using components from that, and then found they struck upon the way these components could be used to passively measure energy. So the first iteration up here is, box from JCar, I think, with some, very rudimentary 3D printed lid that you could run a cable through. And then you can see the iterations, using the 3D printer in the office to get number 2 up there, then going out to a third party to do some 3D printing for us. And now it's, been properly manufactured in a factory and getting ready to go to market. So the whole journey, it started from, a couple of guys at the bench proving out a concept, and then taking the hardware through an iterative process. But then for us, it was also bringing all of our user-centered design type thinking and processes to test it with customers. So this is some photos of people, with their instruction book that they've got in the mail and working out how they're going to get this Internet of Things device connected. And I think about it every time now, like you open, something like some smart speaker or Alexa or whatever, and it's kind of like you just have to touch one button and it's all suddenly going, which is an incredible user experience, incredibly hard to line up all of those things and make them happen. So we're experiencing that firsthand as we do that. But I think it's an exciting example of how we can bring a lot of the practices that we've known and have refined over the years in software and marry them together to create these experiences that people want from hardware now. I'm not sure if folks have heard of this book before. It's got nothing to do with IoT, but it's a great book about just generally business strategy. But there's a chapter in there, Chapter 9, where the author talks about using design for strategic advantage. But he talks about the big example that always comes up in these scenarios is around the space program, where every gram really matters in terms of your non-functional requirement type trade-offs. And it's this idea that every link in the chain matters. So in the book he talks about the Challenger disaster where the O-ring failed, and obviously that was a catastrophe. But it just goes to show when you're dealing with physical stuff, worst case scenario is no longer your website went down and your front page news tomorrow because there's a bunch of unhappy customers. It can mean catastrophe. It can, and we actually see it a lot. We do a lot of work in the energy space, and when you're working with 240 volts and you've got software developers that need to be testing a device, but you've got something on the bench that is very capable of causing extreme harm, we're getting into this very different world now of this bringing together of the physical and the digital side of things. So the trade-offs we make on non-functional requirements are extremely important. Speaking to Zoran, one of our IoT experts at the office, telling us about an example that he'd seen recently of people looking to apply what would be quite obvious sort of solution that would go to in the digital world of trying to put the logic up in the cloud to minimize what's going on the device, because you've got to think about how do you update things once they're in the field, because that can be a massive challenge for an IoT device. How do you update the software or the firmware, that kind of thing? So this idea of, well, let's move as much as we can to the cloud where we can control it. But there was this example of someone working in something very volatile involving fuel, and moved some safety logic away from the device and into the cloud. So what if you lose connectivity? How's that device going to appropriately respond to make sure that everybody's safe? So these kind of trade-offs that we have to think about, it's like, well, it's going to be much harder to get all of that logic onto the device and updated there, but in that case, going to be much safer than having it where the device could potentially not be able to respond appropriately. And that third point there is around the team needing, the team creating the product need to carry a lot of context in their heads. So the guys that I mentioned that work in our office, you know, you go and like eavesdrop on what they're talking about, and it's like another language. Obviously, they're talking about, you know, chip numbers and, you know, very, very low level detail about, you know, how things are arranged on the circuit board and how they're all going to work. But then they also, the same guys, need to have an understanding of, well, what is the business strategy that we're trying to achieve? What's our go-to-market plan? What are the trade-offs that they need to consider in terms of their design of the hardware and the software? It just can't be done in isolation. So it's quite a big ask of people, you know, sort of agile type context where we're wanting to involve the people building the thing in getting the outcome. That's a hell of a lot of context that they need to carry around. So doing a little comparison here, what works well? Applying a test-driven mindset when designing hardware works really well. So some of our manufacturing partners have found that by us providing like what we'd call like a test jig, like a little bit of software that they can have to do testing at the end of the line as those hardware comes off the manufacturing line to make sure it works. Surprisingly, that seems quite revolutionary in the hardware world. So that's us bringing some of our, you know, test first type mentality to really help things in the IoT space. Using techniques such as inception workshops to help the team gain full context. I did that recently in an energy company working in you know, IoT and smart energy, and it was just help people build that full context. It was really valuable. And leveraging the user-centered design techniques as we discussed in terms of that full customer journey to give people what they expect from an IoT device. The challenges, we talked about the design decisions and those trade-offs and the impacts they can have. The long lead time of hardware when you're wanting to get it manufactured is different to being able to run a quick test with software. It is getting better and it is getting leaner and quicker, but it's still hard. And just testing in the field is complex. Another person I asked for some insights into this talked about trying to roll something out, relied on 4G connectivity, and just once you get in the field, the myriad of different factors that you need to deal with, it's harder than our software environments where we're able to control it more tightly. So some key takeaways for me from the IoT space is, you know, under the Agile type banner from our LAST acronym, but I think, you know, there's this, you know, opportunity to learn and iterate and respond to change by bringing some of the things like the 3D printing or finding lightweight ways to get something out to customers and test it is a takeaway. And one very quick final case study to bring it together is in the smart energy space. So you might recognise some of these companies, but they're all in Australian or, you know, doing work here, and similar. They're all chasing a similar goal, and that is around this idea of a virtual power plant. I should have put that on my buzzword list. So just a quick show of hands, who's heard of a virtual power plant before? Most of you. So it's this idea that, and it's really this that's driving it. It's the massive increase in solar on rooftops. That's overload, like, you know, it's going to overload the grid. It's not designed to handle all of this distributed generation, and also creates a great opportunity to be able to manage and control the power that's being generated and to share it with the community of people. Easy to say, pretty hard to do. Obviously, it relies on the utility or the actor at the centre of that being able to do some pretty clever coordination. Now, what we're finding is that there's this strong interplay of the physical and the digital worlds. Obviously, we're talking about solar panels on roofs of houses. But what I didn't mention, but it's sort of this third point, the really key constraint at the moment is batteries. So everyone's got the idea, they can see the potential, but battery penetration just isn't there yet. So it's this this game of how do you ideally be first to market to get the market share in this space and be ready to seize the opportunity, but you need on a mass scale communities, suburbs of people to have enough batteries to be able to unlock this potential. So there's a strong interplay. The sensing and control hardware systems are a major part of the puzzle, but really it's a data play that people need. They need the streams of information coming in and then to be able to respond to that and control which way the energy is flowing. So it's really a data play that these companies are looking at. But there's these economic and psychological barriers that they need to overcome. So the economic one is really around the batteries, and they're just waiting for the day that the price of batteries hit that tipping point. But the psychological barriers is you've got to be okay with the idea of a utility controlling the devices in your house. So, controlling whether your aircon is on or off, or diverting load here or there. And that's, something that we're not quite used to yet. And I think, for me, this is where it brings in the systems thinking part of the puzzle. There's so many things going on. And this is kind of that Industry 4.0 where we're talking about bringing together the physical, the digital, but now we're also bringing in all of these human factors around behaviour change that we need to think about. So there's a lot going on to unlock this massive potential that's there. And, we're working with these types of organisations and just seeing it's pretty mind-bending. You've got teams asked to build out some hardware, the software control systems, and, one of my latest recommendations to one of those companies was to think around, that idea of service design, because who's got the opportunity and the role of starting to pull all of these things together in an end-to-end experience for the customer, and both for the customer and the people working on it. So they're the three case studies I wanted to go through, and just to do a little bit of a overall comparison now, like looking at the digital world versus the emerging tech kind of world. So I think in the digital world we tend to see more generalist, full stack type team members, whereas what we see in the emerging tech world is more specialists with deep expertise, narrower focus, academic or traditional engineer type. So different types of people involved in these projects. In our digital world, we can estimate based on fairly established patterns, whereas in the emerging tech world, everything's new and really fast moving, which makes it harder to estimate. We can operate on the back of experience and intuition in the digital world, whereas in at least the data science, machine learning, relying heavily on research and literature to inform an approach. With digital, we always advocate for co-located cross-functional teams, whereas with at least the example from one of the machine learning people I spoke to said he'd actually rather be working alongside like-minded other specialists so that they can turn around and bat problems around off each other rather than being out on site embedded with the customer. So quite a different kind of mindset there. And for us, in the digital world, Agile is the new normal, whereas, to be really honest, the people I spoke to in the emerging tech world, the jury is still out. They get it, they can see the benefits, but it was by no means, this is definitely going to work, bring it on. They were a little bit like, we're waiting to see how these worlds are going to meet. So, got a couple of minutes left, and to put it back, what does this mean for you and your professional development? That's the question I really want to inspire for you, and I think some of the things came up today in the previous talks, but these are some ideas that I've jotted down. I think it's useful to invest in building some domain knowledge in a vertical, like whether that's energy or machine learning or something, or an area of emerging tech. But I think it's if you want to work in this area or you want to be ready for the future of work, I think having some area of speciality will be good. You might have heard, I can't remember how it goes, but we've talked about T-shaped people. I don't know, is that H-shaped people or something like that, where you need a couple of different verticals now. Maybe one's not enough in addition to the breadth. I I really liked what was it Christina was talking about in terms of like around that idea of partnering. What are you going to ask for from somebody? Because I think, you know, for this type of work, we're going to rely on being able to work with specialists in a particular area. So practicing that idea of building your network and knowing how and when to bring people in. A massive topic which we didn't even get time to really touch on, but I think it's back to that slide with the softer skills and the complexity, but navigating the ethical questions. I think particularly around the AI side of things, that's just going to be an enormous consideration. So systems thinking and people that can help navigate those really messy conversations about how do you find the right path forwards in terms of ethics and technology. And learning techniques to expose the broader system. So I'm basically talking about systems thinking there. So some of these, I'll obviously make these slides available, but I came across this pretty recently, the logical thinking process, which is based on the theory of constraints. It's very complicated, but very powerful. It's a great way of you know, being able to construct or visualize a thought process and all of the dependencies and everything that goes in. And there's this great tool called Flying Logic Pro, which enables, it's kind of like mind mapping, but a bit harder edged and really powerful. There's this technique called consequence scanning, which is like being put forward as a new Agile event to consider incorporating into your workflow, where you consider, and again, Christina, I think, talked about it, consider the human and societal impacts of what you're doing. So turn it into a ceremony where that question actually gets asked and worked through. And there's this great weekly newsletter and podcast called Exponential View. It's broadly around AI, but you know, it's emerging tech, really great interviews. It's one of my go-tos every week that I absolutely make sure I read. So I recommend checking that one out if you're interested in this area. So that's me. Done. A couple of minutes to spare. So yeah, I'd love to hear if anyone's got any questions or takeaways from that.
With the AI, I always find it really interesting, the tipping point where...
Sorry, that's my smile.
The conversation around the tipping point where AI just decides that we are just another disease as humans.
Yeah, yeah.
At what point does it decide that? You know, it's just existential type questions. But I do love the AI sort of stuff and where we're heading with the exponential changes. So it's just more of it's not a question, it's just more of an observation. It's quite exciting stuff.
Cool, thank you.
Just more observational. You know, talking about local networks of power. I find it interesting because you talk about psychological issues around that. Because you know, when I consider getting a battery around a solar panel, the motivation for that would be to cut off from the grid.
Yeah, right.
To take that network out of the equation and just say I'm just reliant on myself. Because I just don't want the hassle of dealing with power companies because have bad experiences, don't like them. So the technology then is allowed me to cut myself off from that group rather than contribute to the greater community.
Yeah. Yeah, it's kind of, that makes me think of the point that was made this morning around the autonomous vehicles and letting go of the idea of owning a car. Yeah. And, you know, so the like pretty much the opposite kind of view of like no ownership. So again, yeah, it's the complexity of the human side of it and the psychological.
I'd actually like to follow up on that because I don't work for this company as a consumer, but I get our power station through PowerShop, and I actually feel quite empowered by actually the app and stuff, and I can actually track and trace and see what's going on in the household, energy, power, etc. So I acknowledge the issues about companies tracking what you do, but actually from a consumer perspective, I find that much better than what used to happen.
Yeah.
Yeah.
So more empowering. Cool. Thank you. We'll take one more because I'm just conscious of time, yeah?
It's about the power thing again,
Yeah.
and how you're talking about the psychological shift, the fact that I do have friends that work in the power industry, and they are working on like how they can control consumer devices within homes to sort of do that power on and off and control the flow. I'm wondering if you can share, like, is there any thinking coming out of the power companies about revenue and how that model is going to change? Because currently we pay for
Yeah, well, there's massive incentives for the power companies around demand response and to reduce the load on their infrastructure. So that's really what's driving them, because they know to meet future demand without doing this kind of thing is this massive. They can see it coming in terms of the network and its ability to cope. So I think that's, I don't know if it's whether you'd say it's a positive kind of incentive for them, but definitely that's one that they're working to. But yeah. Yeah. That's right, the trading side. I'll say thanks and thank you everyone for coming along. If you want to hang around, Ray's going to be continuing in this room, but thank you all. Cheers.